I'm thinking we're going to focus on the GE first, and I think there might be somebody hiding under it right now. Hey guys, welcome back to my series on restoring some vintage color TVs. I apologize for the terrible lighting. I'm recording in a room I'm not usually in, so we'll work it out as time goes on. Oh, let me catch up on a few things. I just got back from the Vintage Computer Festival in Midwest. At the Schaumburg Convention Center, a new location. Had a great time. For those of you who stopped by, it was great talking to you, catching up with some folks, including Doug and Paul from the Vintage Color TV community, who gave me some advice, some insight about restoring TVs like this. I also want to thank all of you for all your comments and suggestions and whatnot. Also, while I was there, I watched other people. I did not record any video on it, partly because I don't like shaky cam videos. And as nice as this camera is, it doesn't have a gyro stabilizer, so it's a camcorder. When I'm holding it and walking around and stuff, it's very shaky. I don't like that. I saw somebody recording with a stabilizer. It was just, they clipped their phone into it and put their phone in video record mode, and they just held it in their hand. And he let me try it out. It's under 200 bucks. I forget the exact brand name, but I was really impressed. So I may very well be picking one of those up, in which case I'll be far more inclined to do the walk around type videos. Anyways, back to this stuff. Now, I left off with my last video asking for advice on, well, where should I go from here? Well, I've decided to take the advice from some of you guys and go for it. And by that I don't just mean plug it in and turn it on. I mean, I'm going to do a slow power up. I'm going to pull the horizontal output tube and plug it into a variac and slowly ramp it up and check the caps periodically to see if they're getting warm and go from there. I also have one of these gizmos. What does this do? You take this out, you find the appropriate adapter for your horizontal output tube, and you pull the horizontal output tube out, you plug it into this, and then this goes into the TV socket, and you can monitor the current draw here. So I know that's a big deal, and they even list here for certain tubes, this is the max current that it should draw. So this will show you how much current is going through your horizontal output tube, and also your flyback, so it will help prevent them from burning up. So we'll do a slow power up without a horizontal output tube, and assuming that goes well, then we can put the horizontal output tube in with this device in there, and we'll see if we can get some light on the screen. Alrighty, you got the back off of the GE set, and there's another wire that's been disconnected. It's going to this guy, which I think is a blue lateral magnet or something like that. Clip on the other end obviously used to go to something, probably ground, probably to the chassis. I'll just leave it floating for now. So we want to pull the horizontal output tube out, which I just did, and what do you want to guess tube this uses? A 6JS6, yeah. If you watched my videos, I only had my Zenith roundie. I had trouble locating a good one. I thought these would use a different one. The RCA does, I'm pretty darn sure. Because I've got lots of horizontal output tubes, but this one in particular is a pain because the CB guys decided to make high power linear amps out of these, and they often use 6 or 8 of them at a shot, and they overdrive them and destroy them, and it's driven the price way up to something like 50 bucks or more for an old stock one. Now, a viewer kindly gave me a couple Foxy branded ones, I think made in Japan. I put one in the Zenith, but I do still have one of those left. If this one's bad, this has a nice shiny getter on it. It doesn't look fried or anything, so maybe that'll be alright. Okay, so what we're going to do, we're going to hook this up to my Suncor DR57, which kind of works like a dim bulb in that you can control the output voltage. So this plugs into the wall and the set plugs into this, and you can set the output voltage and you can slowly ramp it up. There's a red line in here which is 117, which is what your typical normal full line voltage would be that these sets were spec'd for. But this is solid state rectifiers, so there's no rectifier tube in there. I can't pull one out and see if the tube filaments light up. But I'm not really that concerned about that, as I am about other stuff. So ideally we start off at like 10 volts AC or so, and over the course of maybe an hour or two we slowly increase this until we get to 117 while I monitor things. So what's the most likely issue for there to be, assuming all the caps are still good and the tubes are okay, is there's 3 electrolytic cans here, and the caps, the electrolyte can dry out or degrade. Those can start getting warm if they have internal leakage. So we want to check the current draw for the whole set, and this has an ammeter built into it. And we want to check those caps to see if they're getting hot. If you watched my Crosley black and white TV restoration a few weeks ago, a couple months ago, one of those vented on me. A nice big steam cloud of nasty chemicals. So yes, it absolutely can happen. Alright, so let me give you a better viewing angle and we'll get this stuff set up. I gotta dig up a cheater cord and then we're gonna go for it. Output 0 volts. Let's go up to 10. Current draw. We have current draw. We are drawing 1/4 of an amp. Excellent. So, at this low input voltage, there's going to be barely any voltage on those tubes. They are not going to start glowing. They're going to get a bit higher than that. So normally you have about 117, 120 going into this. We have 10 volts going into this, so let's just say it's 1/10. So we got 1/10 of the volt. We got 0.6 volts across the tubes. They aren't going to be doing much of it. So let's go up a little more. So this is an idea. I'll go up maybe 10 volts every 5 minutes. And yeah, it'd be very boring for me to do this, so we'll pause recording and I'll pick up when and if anything actually happens. Up to 40 volts in, and it's drawn 1/2 amp now. And while I've been doing this, I took a paper towel and cleaned off the tubes a bit, and I noticed something. I do believe, with the exception of the horizontal output tube, these are all GE branded tubes, meaning they might all be the original tubes. Okay, we're up to 70 volts in. We're starting to see tubes glowing. And current draw is steady. Caps are cold. Last time I turned it up, or when I went from 90 to 100, there was a brief current spike and it came right down. I heard a little crackle of something in here. I'll run to the front, change the channels, and play with the volume. So I thought we would at least hear something out of the speaker at this point. No. Now, it could also just be that in the absence of a signal, it's just a pretty quiet set. Is that a heart attack? The dog just barked at a ghost or something, I don't know. Made me jump. Cold. Alright, we're It's like 105 now, so. Current draw. Now it's not drawing that much current. It's only drawing about 0.85. And it's supposed to draw, well, 350 watts max, which is more like 3 amps. So we're drawing less than half of what it should be, which doesn't seem right. Which makes me wonder, maybe like the diodes are blown and there's no B plus going to the set, and all we've been doing this whole time is just powering filaments. Alright, here we go. Yeah, I strongly suspect that we have no power going, and that would explain why there's no crackle from the speaker or anything. Alright, here we go. So current draw shot way up because of the cold tube filaments, and we've got no current draw on this guy. Another good indication is as the tubes warm up, this needle's not moving. If we'd B plus as the tubes warmed up, this needle should be going way off scale. So let me try pushing the circuit breaker button. No, nothing. And I think I looked, does that circuit breaker? I think it does the whole set, but I was thinking maybe it's just on B plus, but it's the whole set. Okay, so there we go. We have no power supply. Which could be a very good thing, because maybe there is a shorted cap and it took out one of the rectifiers and everything else is just fine. And so the set, in other words, the set just stopped cold because of a failure in the power supply, and everything else can be perfectly fine. Alright, the downside to that is that's going to take some work. I don't know what the rectifiers are. If they're underneath the chassis, I got to pull the chassis. So, which I don't think is too horrible. I can disconnect a bunch of stuff. CRT socket. Oh, that's a drag. I was hoping all the harnesses that go up to the tuner and the speaker and the controls, was hoping it would plug into the chassis. It doesn't. It goes from the chassis. I hope they're not high wired in. Geez, that would be a real pain in the butt. Or they're on connectors that are on the other ends. But no, come on guys, don't tell me it's hardwired. You know, it's like the power switch, it looks like it's hardwired right to the chassis. Oh crap. Sure, let's do some fireworks on a Saturday night. Oh hey, there's stuff in here. No, it's not graphite. I don't think it is. We've got bits and pieces of things floating around in the cabinet towards the front. There's a screw. I don't know what that's all about. Piece of, oh. Fragile glass pitch tube is dangerous to service for the qualified service personnel. Yada yada yada. Yeah, so here's what I pulled out. So here's what I'm moaning about. We got a whole bunch of cables coming out of the left side of the chassis that go up to all this stuff. It looks like everything's hardwired. Okay, the antenna inputs are not hardwired to the tuners. We can disconnect those. We disconnect the speaker. But like that whole control block down there with 7 pots on it, it's all hardwired. So unless that board comes out real easy, which I can tell it does because it's got a whole bunch of screws on it. Well, what the hell? I mean, yeah, there's some length on the wires. I could pull the chassis and flip it over and probably, no. Some of these sets, if the chassis is securely bolted down, you can put the set on its side. And there's an access panel you can get at through the bottom and get at everything. But no, Unless his board well, maybe. There's something with... I'll try tipping the set on its side in a bit and see. There's a board with slots cut in it. I don't know if it's... Oh yeah, no, the slots go right through the bottom here. I don't think it's a removable panel at all. Man. I'll tell you what, I will look through the SAMs, because it's a bunch of pages, and they generally do give tips on like how do you actually pull the chassis and such. So we need to find the rectifier diodes that go right from the output of this transformer to these filter caps and power the set. I don't see them sticking out of the top here, which makes me think that they're underneath the chassis. Here's a schematic for the GE, and I see I was wrong. The circuit breaker is just for B+, and the filament is separate. And actually, this is the main one, and it's fused with just the length of small gauge wire that would burn open. So it's entirely possible that the circuit breaker's bad. They are flaky. Otherwise, like this rectifier could be open. Yes, the power transformer could be bad, but we're not going there. We're not going there. Either way, I don't think I can check either one of these without pulling the chassis. Okay, this is what I was talking about. Disassembly instructions. TV chassis removal. Remove 9 screws holding back cover. Did that. Disconnect yoke plug. High voltage. Convergence board. Remove 5 screws holding chassis. Lift out chassis and tuner. Most components may be serviced without removing chassis. I don't know about that. Well, let me muddle my way through this. Gee, you think these might all be the original tubes? I do. Let's finish off this video by testing them, shall we? One thing I noticed is a slight difference between some of them. Sometimes, if you got your set serviced by a factory authorized dealer, you'd get the same brand tubes, be it RCA, GE, whatever, but the color of the printing would be slightly different. But, well, we do have date codes now, so 6452, 6452, 6452, which dates the set pretty well, late 64, 6448, 6420, 6443, so that'd be 1964, 43rd week, 6443, 64, 64, so yeah, these, which means the set probably was never serviced. Now, yeah, we do have an RCA tube for the horizontal output tube, so maybe that one tube was replaced, or maybe they used an RCA tube to begin with. Maybe our GE just didn't make that type. I don't know. But also, very likely, a low-hour set was confirmed by how good the CRT tests. Now, most of my tube testers are pretty old. Like a Hickok 600, it cannot do Compactron, so I pulled out my Suncor TC162 Mighty Mite 7, which most certainly can, and so far they're all testing well into the good. Just about done. All these tubes test like new. These show shorts, and this shows excessive grid leakage. However, the shorts and grid leakage test on this tester is very sensitive. A lot of testers don't even test for grid leakage. I suspect if these were put in the set, it would work alright. These in particular, I believe, are used in the IF, and they tend to get driven a little bit harder and get some grid leakage. The 16GH8, the tube I'm always hearing about, are crappy tubes, or they're used too hard, and they're always bad. It only has one, and it's good. We got 2 more to test. Well, I'm just going to go ahead and replace those 3 tubes. So that's going to be it for now. I'm going to pick up next time, hopefully when I've figured out how to get the chassis out without going to extraordinary lengths, and we can figure out what's going on with the power supply. Thanks for watching.